For over 2 million years, human survival required constant motion. During the Paleolithic era, small bands of hunter-gatherers tracked herds and foraged across changing landscapes, rarely staying in one place long enough to leave a permanent mark. Around 10,000 BCE, that nomadic imperative ended. The archaeologist Gordon Childe identified this pivot as the Neolithic Revolution. Humans figured out how to domesticate plants and animals, effectively manufacturing their own food supply and enabling them to build the first permanent settlements. Looking at this map, agriculture took hold first in the Fertile Crescent, but as we pan over to the Indian subcontinent, the transition doesn't happen all at once. Instead, it unfolds as a delayed, highly diverse cascade of regional adaptations. Across all these varied Indian sites, archaeologists look for 4 specific markers: polished stone tools, evidence of domesticated agriculture, signs of permanent architecture, and the production of pottery. The Neolithic marks a transition where geography begins to dictate how communities organize. By staying in one place, humans shifted from opportunistic foraging to a system of long-term planning and local land management. To clear dense forests and till hard soil for crops, the tiny chipped stone microliths used by earlier Mesolithic hunters were entirely useless. They simply lacked the weight and structural durability to dig into the earth. Look at these heavy ground stone celts, the defining technology. Notice the pitted texture on the left tool, shaped by pecking. Grinding achieved the smooth finish on the right, allowing the blade to penetrate deep soil. These polished tools were highly efficient, allowing early farmers to generate massive grain harvests. But a massive harvest immediately creates a new vulnerability. Stored grain attracts pests and rots when exposed to moisture. This ceramic vessel represents their engineering solution. Firing clay into pottery provided the secure volume needed to store food over the winter. Early Indian sites feature specific styles, like black burnished and cord-impressed wares, mapping directly to this storage imperative. By applying friction to stone, humans engineered an agricultural surplus, and by firing clay to protect that surplus, they removed the necessity of constant migration. Because early agriculture required deep, fertile soil, human migration routes tracked strictly along major river valleys. Here, the path moves from the west straight into the Bolan Pass region. This photograph shows the ruins of Mehrgar, established around 7000 BCE. Situated right next to this vital river, it's the earliest transitional site for wheat farming. When harvests proved reliable, inhabitants invested in permanent, overground architecture. Examining these excavated foundations, you can see the precise rectangular geometry of mud brick walls. These compact compartmentalized cells functioned as granaries to secure the yield. Mehrgar also yields highly specific biological data. Human remains excavated here provide the earliest recorded evidence of primitive dentistry performed on living patients. Archaeologists also found multiple human graves, where the deceased were interred alongside the bodies of domestic goats. The presence of these grave goods suggests a growing material investment in the dead. While ritual existed in earlier nomadic groups, a stabilized sedentary life allowed for more permanent and resource-heavy expressions of belief in an afterlife. Moving to the extreme north, the climate in the Kashmir Valley presented a severe freezing threat. Sites like Burzahom and Gufkral reveal a completely different set of architectural survival strategies. Instead of building exposed structures above ground, these populations dug deep, circular pit dwellings directly into the earth to insulate themselves from the harsh winters. Their burial rituals also deviate significantly from the northwest. Here, human remains are frequently found buried with their domestic hunting dogs. If we follow the map southeast into the Ganges Basin, the environment shifts to dense, humid riverine jungles. At sites like Lauhareva, dating to 6500 BCE, we find some of the earliest evidence of rest cultivation. Nearby, at Mahagara, the archaeological record includes the distinct layout of large cattle pens, with the actual hoof marks of the herds still preserved in the fossilized mud. Further east in Bihar sits the site of Chirand, uniquely positioned at the massive confluence of 4 major rivers. This location created an engineering paradox. The alluvial floodplains provided excellent soil, but lacked the hard stone needed for Neolithic axes. In response, the inhabitants manufactured a highly advanced, specialized toolkit, almost entirely out of deer antlers and bone. You can see that there is no single standard Indian Neolithic. Depending on whether they faced freezing valleys or stoneless floodplains, human populations engineered specific adaptations to make agriculture function. Tracing the migration further into Assam and Meghalaya brings us to sites like Daujali Hatting. The timeline here is significantly delayed, with Neolithic characteristics appearing much later than in the West. The artifacts excavated here, including yams, cord-impressed pottery, and imported jadeite, point directly to heavy cross-pollination and trade routes connecting the subcontinent to China and Southeast Asia. Now look at the extreme opposite end of the subcontinent, the rocky, semi-arid terrain of modern-day Karnataka and Andhra Pradesh. The lack of deep alluvial soil and the drastically lower rainfall made the cultivation of water-heavy crops like wheat and rice physically impossible. To survive this environment, southern populations pivoted to cultivating highly drought-resistant millets, specifically ragi and horse gram. Because agriculture was difficult, their economy relied heavily on cattle pastoralism. This reliance produced the most distinct archaeological marker of the South Indian Neolithic, massive formations known as ash mounds. These sprawling mounds are the result of inhabitants collecting immense volumes of cow dung from their pens and burning it in repeated, massive ritual fires. Even in a rocky landscape deeply hostile to traditional farming, the core Neolithic drive persisted. Populations extracted resources, domesticated herds, and bent the local environment to their will. Agricultural surplus anchored populations to territories, forming fixed village hierarchies and rules around collective land ownership. This surplus birthed specialized labor, allowing individuals to focus entirely on pottery or toolmaking, generating early barter economies between settlements. This system eventually reached the limits of stone and bone. While effective for subsistence, they lacked the durability and malleability required for larger-scale tool production. The next transition began. Metal tools disrupted the relatively egalitarian structure of the Neolithic tribe. Control over copper resources allowed for more pronounced social differences, concentrating wealth and power into the hands of emerging chiefdoms. Solving the baseline mathematics of food production provided the necessary biological and architectural foundation. Without these early agricultural engineers, the sprawling urban empires of Indian history simply could not exist.